Hey YouTube, I'm going to talk to you today about a project that I recently completed. It is a Razor DXT drift trike. If you're not familiar with that, it's a pedal powered drift trike made by Razor. I converted it to run off of an electric motor, specifically a 1000 watt 48 volt electric motor. I'll provide a list to the different parts that I used. First, kind of a primary design parameter that I used when putting this thing together was I wanted to reuse the wheels that come on the Razor drift trike. So when you disassemble the Razor, you'll find that the inside diameter of the wheels, and specifically the wheel bearings that come on that drift trike, are 12 millimeter. So from there, I procured different components like pillow mounted bearings, axle, the sprocket, collars, different couplings, and they all had a 12 millimeter diameter. If I was to do it over, I probably wouldn't do it that way, but this is what you learn from these projects, you know, how you would do it different. From a power perspective, the combination of the motor and the batteries, it runs pretty good. With me on it, I can run it up to about 25 miles an hour. My son, I think he actually got it up to about 27 miles per hour. I weigh 175. He weighs under 50 pounds, so he's 6 years old. But yeah, I'll show you some of the stuff I put together here. So here's the drift trike. As you can see, we do have a few Razor products. I took apart the dirt bike and the scooter, and that kind of gave me some education on how I might want to put together this drift trike. But the heart of it is a 1000 watt. It's called a My 1020 motor. I bought this off of the motor off Amazon, and it came with a T8F gear. So that gear that goes on the end there, that's called a spur gear. And what it came with was T8F, but I wanted to use a number 25 chain. My other Razor products use a number 25 chain, so if I wanted to replace the motor on the scooter or on the dirt bike, I want to have similar components. So from there, I did have to order a new gear on the end. This is a smaller chain. And then this gear here, it's a 52 tooth sprocket. So I got 13 on this one, and then I got 52 on this one, which gives me a 4-to-1 gear ratio. So essentially what that translates to is whenever this small gear turns around 4 times, this big gear will turn around once. The other factor to consider is the RPMs on the motor. So this motor in particular, you'll see, is rated at 3000 RPMs. And if you want to get the, I guess the theoretical miles per hour, you would then just take the diameter of the wheels, which these are the stock Razor wheels that came on this DXT, and they are 32 inch in diameter. So with a little bit of math there, you can get to what the miles per hour is. On the battery side, it's running off 4 batteries. These batteries are wired in series. So here, to run it in series, you just connect the plus to the minus, and the plus to the minus, plus to the minus, and then that's going to multiply your voltage. These batteries are 12 volt and 10 amp hours. This is something else that I found on Amazon. Whenever you're shopping for a battery, you need to look at the discharge rate. So the depth of discharge and how quickly it can discharge, essentially, also known as the C rate. I could post a whole separate video on that. But the other kind of important components of this build is how the wheels attach to the axle. So originally, and you can see the original axle stud that came on the DXT right here. So originally, these wheels are designed to go on here and to spin on a bearing that's inside the wheel. Well, I wanted to create something called a live axle, which means the entire axle turns. So rather than just the wheels turning independently, the entire axle on this drift trike turns. So an important piece of hardware was this this flange that you can see down here between the pillow-mounted bearing and the wheel. And this flange enabled me to bolt into this plate. That plate's actually a 4-inch outlet cover that you would put on like an outdoor electrical outlet. But I came straight out of there and directly into the wheel with some screws. Those are going to loosen up over time. I screwed them in there and put some super glue on them, but they're probably going to back out, at which point I'll go all the way through the wheel. But I'm thinking that these wheels, unless I put some sort of PVC on them, probably won't make it that long. And then the other piece is what's called a pillow mount for a bearing. That's right here. And those the axle just goes through those pillow mounts for you to so the entire axle will turn. And then on the outside, the other thing I did, it's not easy to find a 12 millimeter steel rod. I actually had to source this from a place that just specialized in metal, but I got the steel rod and I threaded it. So I used a die, and I don't know if you've heard the term of tap and die, but I essentially used this right here to put onto that metal rod and to thread it. And then once I threaded it, I just put a 12 millimeter nut on there, and then that's a spacer that I got at Lowe's with a washer. Now, as far as attachment, you can see that I attached the deck just with U-bolts, and those U-bolts go around actually under the frame. And then I put some spacers in there so that I could really lock that down nice and tight. So I used 3 U-bolts to fasten the deck. Now, the other piece, though, that's pretty important is these extenders. So these steel extenders that you can see here, those are actually welded. A friend of mine welded those on. Originally, I was going to use a tap and just drill out some holes on this hub under here, and then bolt the square tubing directly to the back of the razor. At the end, I decided I might as well go ahead and get it welded, and a friend of mine welded it. And then, I'm not 100% sure the tensile strength of the bolts and whether or not it would hold all the weight of this. So this is what it looks like behind the wheel. It does have a key that you turn on. I put some other stuff on here, like an attachment for a light, and for a cell phone to do like GPS miles per hour. But I'll give you a little sample of what it's like to drive this thing. So it's a little bit chilly today, and one important piece of equipment when riding the drift trike is some goggles, because it made my eyes water. But it's good for speeds up to about, with the 4-to-1 gear ratio, speeds up to 25, 27. If there's interested in seeing the entire build, I will post some video and pictures of the entire build of the drift trike. The next iteration of my design is I'm thinking that I want to do a 2-speed on the rear sprocket. So do a 52 rear sprocket, 52 tooth, and then maybe like a 33. And then also I'm looking at some options for brushless electric motor. And that'll bring the RPMs up to about 4250. So lots of lessons learned, lots of potential ideas for the next iteration of the project. Thanks for watching.